Flows are a new capability in Liquibase Pro that makes it easier than ever to implement consistent, well-governed automated database change management, no matter what databases or tools your teams are using. Flows are YAML files that define multi-step Liquibase workflows. They can contain Liquibase commands, shell commands, or calls to shell scripts. They can even call other flows. Flows can also read configuration information from many sources, such as system environment variables, Liquibase command line parameters, or properties files. You even have the option of defining variables within a flow itself across multiple scopes for maximum flexibility. Once your flow is established, any team can begin using it on their desktop or in their delivery tool chain. All they have to do is provide the appropriate runtime properties and execute a single Liquibase command. Sharing flows across teams and tools ensures that all database change activity is being consistently validated, governed, and traced throughout the SDLC. In this demo, I'm going to run the same flow locally on my desktop and in a GitHub action to validate the changes I'm making to my database as part of my project. As you can see here, I've got a very simple change. I'm just creating a 3-column table to add to my schema. And this is the flow that's going to run that validation and make sure that everything is good to go for this to be integrated into the rest of the project. Now, my flow file is broken into stages. The first stage is validating the changelog. And the actions, I'm running 2 actions, so I'm running 2 Liquibase commands, validate to make sure that the changelog is well formed. And I'm also running checks against that changelog to make sure that none of my programming patterns have caused any issues with what's expected out of our changelogs. Our next state is called generate update information. And there's 2 things I'd like to note about this. First of all, there's an if conditional here. So this stage the action in this stage will only run conditionally if this evaluates to true. So really I'm looking for what kind of environment I'm in, which I'm specifying in a property that I'll show you in a second. And if I am not in a dev environment, we'll go ahead and run this flow. If I am in a dev environment, we won't. And we're calling another flow file. What this flow file does is it tags the database, it runs status to show everything that's happened previously, and it also will generate the SQL that's going to be executed as part of that update. So by including this information and standard out our log files in our build system, in our continuous integration system, we've then got that to refer back to for troubleshooting or auditing needs. Because I'm in my development environment and I'm doing this all the time, I don't really care about generating that information. So that's why I have the conditional in here. I'm going to skip this step locally, but it will run in the GitHub action. Our next stage is to update. So I run Liquibase update. And the stage after that is to run our database checks to make sure that everything is acceptable and my change can be safely integrated into the rest of the project. All of these stage names are arbitrary. I came up with them just as you will when you're writing flows. There are some structural components that you have to adhere to, so the actions and how those all break out, and that's really well documented in our docs site. So I am going to go ahead and run this locally. And when I do, the configuration information is going to come from my properties file. So here you see some pretty standard configuration properties for Liquibase that I'm sure you've used several times. But at the bottom, I've got a couple of additional ones that are specific to my flow. First, I'm defining that, yes, this is a development environment. So please don't run that step where we generate the additional information. I'm also pointing to the directory where my flows live because it's a little different here than it is on GitHub Actions just because of the structure of my repo. When I run it on GitHub Actions, all of this information is going to be defined as part of the environment in that action workflow. So as you can see here, I've got all of the same properties defined here, and those will be used when it's running GitHub Actions. And it'll skip what's in that Liquibase.properties file. This is the key to flows. When you look at the flows, you notice there's not a lot of environment specific. There's not really any environment specific information in them. It really is about those steps you need to take as part of the workflow. We use those variables and properties to tailor it to the environment we're in or the project that we're working with. As you can see, there are several different things in this one. My host name is different. The username and password are different. There's all sorts of things that you can do to sort of change based on your runtime and have those flows work. So I'm all set up here. I'm going to go ahead and run this locally. And if that goes well, I will go ahead and commit it source code control and have the GitHub action run. Okay. So let's see here. We've got our flow has executed. Our first stage, validate changelog, it ran the validate and the checks run command, like I said it would. It looks like we're only checking for the presence of drop table in our changelog. That wasn't there, so we're good to go there. No rules violated there. Then we go to the generate update info stage. And as you can see, we're skipping that action because I had defined dev as, the environment here, and that made that evaluate to false. So we're skipping that stage because we're in dev and I don't care about generating all that extra information. Then we get into our update stage, and it's pretty straightforward. We run the update. We execute quality checks against that end state of the database. And it looks like I did trip one. It's about all my tables must have a comment just to make it easier for other people to understand what's going on. This is an optional one. The return code was 0. I'm not going to do anything about that before I push it to GitHub. But everything went successfully here. So now what I'm going to do is commit my changes, and that will trigger the GitHub action. And what we'll see in the GitHub action, it's really simple. All we're doing is checking out our project, and we're running that same flow file. So it's my validate changes update db.yaml. I'm keeping it in source code control, but if you're wanting to maintain one flow for multiple teams, you could put it in its own repo, or you could put it somewhere on a file share, S3, something like that. So everybody's operating off the same file. The great thing about that is that you're able to change the file once, and all the teams that use that file are automatically updated. And so that's where a lot of the convenience and the fast rollout across multiple teams comes into play. So let's go ahead and commit our changes here and sync our changes. And we will head over to GitHub for the rest of our demo. So it should pick up those changes in just a moment and start running. Okay, here we go. It took a little while to refresh there, but this is the result of the job that I just ran. We can see that everything went well here too. So when we click into our step where the flow is run, we see very similar output to what we saw locally. Here we are, we're in our validate changelog phase. Yes, it validated. Yes, checks were run. I came back with the same information, no drops, so I'm good. Next, we went to generate update info, and this time it did not skip it. It's going ahead and executing that flow because I didn't have that flag set in dev. So it tagged my database. It ran status on my database so I could see what had happened before, or so I could see the pending change. And then it generated the SQL that's going to be executed as part of that update. So I've got all of that in the same log file through this continuous integration process. There was not an end stage in that file, so we went back to our original Liquibase flow for our update. The update happened. We ran database checks. Our same database check came back, but again, it's informational, so it didn't break the build. And that was that. Using flows to abstract your ideal workflow from the specific details of any one project allows you to easily manage safe, compliant, and traceable database changes and automation across your entire organization. Your teams will deliver higher quality application experiences faster and more frequently with less toil, leading to happier teams and happier customers. If you want to know more, check out our documentation.